All right, moving on to section 5.2 now. We are going to be looking at exponential functions and their graphs. So exponential functions look something like f of x is equal to a to the x power. And this can vary very significantly based on whatever little exponential base you're using. So I have two examples here that I want to show you of a base that is specifically larger than 1 and a base that is specifically between 0 and 1. Okay, so if I pick something like f of x equals 2 to the x power, and I'm just going to plug in from negative 2 to 2, so we have a pretty good picture of this graph. When I plug negative 2 into my exponent, 2 to the negative 2, remember our exponent rules. Negative exponents move the exponential base across the fraction line, or you can think of it as flipping it, right? So this becomes 1 over 2 squared, and then I can simplify that to just 1/4, right? Same thing with negative 1. If I plug in 2 to the negative 1 power, that's going to flip it, right, or move it down to the denominator, which gives me 1 over 2 to the first power, which is then just 1/2. Okay, 2 to the 0 power, well, anything to the 0 power is 1. 2 to the first power is 2, and 2 squared is 4. So we're going to go ahead and graph this just to see what it looks like. Okay, let me see if I can get this a little bit straighter. There we go. All right, so when x is negative 2, I'm at 1/4, which is just above 0. When x is negative 1, I'm up at 1/2. When x is 0, I'm at 1. When x is 1, I'm up at 2. And when x is 2, I'm up at 4. So you can see our function looks something like this, which is an increasing function, right? Now, if I were to keep plugging in numbers out here to the right, when I plug in 0, I get 1. When I plug in 1, I get 2. When I plug in 2, I get 4. If I were to plug in a 3, 2 to the third power is 8, right? 2 to the fourth power is 16. 2 to the fifth power is 32. So this is going to shoot up really quickly, really steeply, right? In the opposite direction, notice what happens at negative 1, it flips it, and I'm at 1/2. Negative 2, it flips it, I'm at 1/4, which means that negative 3 would flip it, and I'd be at 1/8, and then 1/16, and then 1/32, and then 1/64, and then 1/28, right? So when the bottom of the fraction is getting bigger and bigger and bigger, the entire value of the fraction is getting smaller and smaller and smaller. So this side is getting infinitely small, but it's never going to equal 0, right? It's just going to get super duper 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 close to it. So when something gets super duper 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 close to something, but doesn't touch it or equal it, we say that there is an asymptote here, which I'm going to write as a dotted line. I don't know if you can really see that. You can also use a highlighter, excuse me, to show that there is an asymptote at y equals 0. That means this is going to come down and get closer and closer and closer to 0, but never touch it or cross it. Okay, and it's important that you put the y equals, not just asymptote at 0, because when you write y equals, that lets me know that it's an entire line that this function cannot come down and cross. Okay, all right, let's look at what our shape looks like when we have an exponential function with a base that's between 0 and 1. So let's look at 1/2 to the x power. When I plug in negative 2 in for my exponent, I get 1/2 to the negative 2. Remember, the negative exponent flips it, so we're going to flip it, excuse me, which gives me 2 now to the positive 2 power. Because when I flip it, I get 2 over 1, and that also changes my exponent to positive. So this just becomes 4, right? When I plug in a negative 1, 1/2 to the negative 1 power, is going to flip it and change the sign of my exponent. So that's going to give me 2 to the first power, which is just 2. And when I plug in 0, I'm going to get 1/2 to the 0 power, which anything to the 0 power is 1. 1/2 to the first power is just 1/2. And 1/2 to the second power means I'm squaring 1/2, or squaring the 1 and squaring the 2, which gives me 1/4. Okay. So notice these are very similar to what I got over here, right? It's just over here when I plugged in negatives and I flipped 2, I got tiny fractions. And when I plugged in positives, I got big numbers. Well, if I start out with a fraction and I plug in negatives, that's going to flip them and give me big numbers, right? And when I plug in regular numbers, I'm going to get smaller fractions. So at -2, I'm up at 4. -1, I'm up at 2. 0, I'm up at 1. 1, I'm at 1/2. And 2, I'm at 1/4. So this looks something like this, which again is a nice exponential function, but this time it's decreasing, right? When our base is greater than 1, we get an increasing function. And when our base is between 0 and 1, we get a decreasing function. Okay, notice here, the right side of this function is still getting closer and closer and closer to 0, but not touching. So this one also has an asymptote at y equals 0. Okay, I don't know which one is easier for y'all to see, the dotted line or the highlighting. So whenever we graph these, we need to make sure that we're able to find not only the graph, but that we can state domain and range and the location of our asymptote, right? So on both of these, our asymptote is at 0. And then I'm going to go ahead and write the domain and range of each. Our domain on this first one, remember, domain is our x's. How far to the left to how far to the right is this going to go? And notice to the left, this can keep going back and back and back and back and back, right? Because I can continue to plug in negative exponents. So that's all the way back to -infinity. To the right, I can continue to plug in positive values into the exponent. So -infinity to +infinity. And then our range is our y values. So notice this is where we have a problem, because this asymptote is kind of like a force field saying it can't go past this, right? So it's going to start, our lowest y value is at 0, but because it can't touch or cross, it's never going to take on the value of 0. So we're going to start at 0, but we're going to start with a parenthesis to show that it's not actually going to equal 0. And then our y values can be anything bigger than 0. Okay, and the same thing on this one. If I look at my domain, this one's going to keep going left and right. So domain is -infinity to infinity. Our range is our lowest y value, which in this case, again, is still 0, up to our highest y value, which is infinity. Okay, and then both have an asymptote at 0. So, cool thing about exponential functions, their domain will always be all real numbers because it's always going to keep going in both directions, right? And then our range we can figure out based on the location of our asymptote. So what we're going to look at now is taking an exponential function and transforming it. So remember, with transformations, that's our HSRV process, we need to know when something is happening inside the function and when something is happening outside the function. So when we're given an exponential function that looks something like this, notice where our x's are is up in the exponent. So anything that happens up in the exponent, we're going to say that's happening inside the function. So we know that's something that's being applied to the x, right? Now, if it's outside the function, that means it's not in the exponent and it's being applied to the y, right? So that would be things like out in front of this a, things being added or subtracted out here would be outside the function, which we know would relate to y. So let's look at this first one. First, before we start identifying transformations or anything else, we want to make sure we know what the exponential base is. What is the thing with the exponent, right? In its most basic form. So in this case, it would be a 5. The 5 is the thing with an exponent. So we're going to go ahead and go down here and create a parent table using 5 to the x power. So I'm going to use -2, -1, 0, 1, and 2. And a lot of times, I know we've just used like 3 points when we do transformations, but with exponentials, we really want to use 5 so that we get a good shape. And it's easy to see where our asymptote is. So when I plug in -2 into my exponent up here, the negative tells me I'm going to have to flip it, which will make it 1/5. And then the 2 tells me I'm going to square it. So that will give me 1/25. -1, the negative flips it, makes it 1/5. And then to the first power is just 1/5. 5 to the 0 is 1. 5 to the first power is 5. And 5 squared is 25. Now the graph we're given is just a 12 by 12. So I'm going to go ahead and just mark out this other one. That's a little too steep to be trying to graph on our coordinate system here. Okay. So now that we have our parent function grid, now we need to identify what transformations have happened. So you can see we have a -2 up here in the exponent. And as you can see up here at the top of our page, if it's up in the exponent, it's inside the function, which means it's being applied to the x. So x -2 actually sends our graph to the left, right? So that's a horizontal shift to the left 2 units. So we're going to take our x's and subtract 2 from them to modify that table, okay? And then the +3 that's over here, notice it's not inside because it's not in the exponent. It's outside, right? So if it's outside the function, then it's being applied to the y. So that's going to be a vertical shift up 3. So we're going to take our y's and we're going to add 3. Okay. All right. So now that we know all our transformations, we're going to take our parent function table here, our 5 to the x, and just apply these transformations in HSRB order. So we're going to do our horizontal shift first. So now it looks like 5 to the x -2. And to apply that transformation, we take our x's from the first table and we subtract 2 from them. So -2 minus 2 gives me -4. -1 minus 2 gives me -3. 0 minus 2 gives me -2. And 1 minus 2 gives me -1. Okay. My y's stay the same. 1/25, 1/5, 1, and 5. Then we do our next transformation, which is our vertical shift. So now it looks like 5 to the x -2 plus 3. So to move it up 3, we're going to take our y's from the previous table and add 3 to them. So 1/25 plus 3 is 3 and 1/25, right? 1/5 plus 3 is 3 and 1/5. 1 plus 3 is 4, and 5 plus 3 is 8. And then my x's stay the same. So -4, -3, -2, -1. So we're going to go ahead and graph this last table. So when x is -4, we're up at 3, and 1/25, which is teeny tiny fraction just past 3, right? At -3, I'm up at 3 and 1/5, which is not much further up. -2, I'm up at 4, and -1, I'm up at 8. So we can see we get that good shape. And we can see here that instead of our asymptote being down at 0, right, because we shift this whole function up 3, now our asymptote should be up here at y equals 3. Okay, and again, make sure you highlight it or you put a dotted line or something so that you know it does not cross that horizontal line. Okay, and then we want to find our domain and range. So domain of any exponential function is from -infinity to infinity because it keeps going left and right. And our range in this case is our lowest y value, which is where asymptote is at 3, up to infinity. And we want to make sure we use a parenthesis to show that it does not equal 3, right? That is our asymptote. All right, we're going to look at about 4 more examples, and I'm going to give you all some to try. So first thing, always identify the thing that has the exponent on it, because that is your base. Not the negative, right? Just the base. So we're going to start with 1/2 to the x. And I am losing my voice. So I'm going to do my best not to cough, but I may not talk through every single little thing that I'm writing. So I'm going to go ahead and put -2 to 2, and then I'm going to fill in with those values. And then I need to identify my transformations. The negative that's out front is outside the function, so that's negating the y's. So that's going to be a reflection about the x-axis. And we're going to change the sign of our y's. The +3 up in the exponent is a horizontal shift. It's going to move it to the left 3. So we're going to take our x's and subtract 3. And then the +2 outside the function affects the y's. That's going to be a vertical shift up 2. So we take our y's and we add 2 to them. Okay. So now we're just going to modify this table one transformation at a time. First being our horizontal. So we have 1/2 to the x + 3. So we're going to take our x's and subtract 3. And we didn't do anything to our y's, so they stay the same. Then we want to move on to our reflection. So now our function looks like -1/2 to the x + 3. And all we're going to do is change the sign of our y's. And our x's stay the same. And then the last thing we need to do is our vertical shift. We do our vertical shift by taking our y's from the previous table and adding 2 to them. And our x's stay the same. Okay, and again, if fractions mess you up, you can always convert them to decimals so that whenever you simplify at each stage, you can just use a decimal. Okay, either one is fine with me. So let's go ahead and graph it. At -5, I'm down at -2. -4, I'm at 0. -3, I'm up at 1. -2, I'm at 1.5. -1, I'm at 1 3/4. So you can see this is creeping up here closer and closer and closer to 2. So that's where my asymptote is going to be. Okay, so again, either highlight it, draw a dotted line, something so that I know you know there's a force field there that your line cannot cross. Okay, our domain on all exponential functions is -infinity to infinity. Our range is our y values, so lowest y up to highest. And then our asymptote is at y = 2. Okay, let's look at another one. Just like the last one, we need to make sure we identify our base first, which in this case is 1/3. So we're going to do 1/3 to the x power to start off with. I'm going to go ahead and fill in with the values. and then identify our transformations. And normally we see our transformations written in the opposite order. We always see our x written first. So if it helps, you can always rewrite this as f of x is equal to 1/3 to the negative x plus 2. If that helps you to better identify your transformations. Either way is totally fine with me. Okay. The negative in front of the x is a reflection about the y-axis. So we're going to change the signs of our x's. And then the plus 2 up in the exponent is a horizontal shift to the left 2. So we're going to take our x's and subtract 2. So we go ahead and start modifying our table one transformation at a time, starting with our horizontal transformation. So this is 1/3 to the x plus 2. So we're going to take our x's and subtract 2, which gives us -4, -3, -2, -1, and 0. We didn't do anything to our y values, so they stay the same. And then we do our reflection about the y-axis. So it looks like 1/3 to the negative x plus 2. So we're going to change the signs of our x's. Okay. So that's going to give us 4, 3, 2, 1, 0. And our y's stay the same. 9, 3, 1, 1/3. 1/9. So now that we've done all our transformations, we want to go ahead and graph it. So at 4, I'm up at 9. At 3, I'm up at 3. 2, I'm up at 1. 1, I'm at 1/3. And 0, I'm at 1/9. So we can see here, we get a nice increasing function, and our asymptote is right on top of our x-axis, right at y equals 0. So domain for all exponential functions is -infinity to infinity. Our range in this case is going to be from 0 to infinity, because it can't go below our force field asymptote here, right? And then it continues on up. And our asymptote is at y equals 0. Again, make sure you write y equals, not just 0. Okay. I'm going to look at 2 more, and then I'll have y'all try a couple. Okay. So on this one, again, this does look kind of funky. We're used to seeing the exponential base written first. So I'm just going to rewrite it. You don't have to, but if it helps you to rewrite it, go ahead and write it with the exponential base first. And then your constant term at the end. Just make sure, the sign that goes in front of it stays with it. Okay. So our base here is a 2, not the negative, just the 2. So we're going to start with 2 to the x. And again, I'm going to plug in -2, -1, 0, 1, and 2, which gives me 1/4, 1/2, 1, 2, and 4. And then I'm going to identify our transformations. The negative out front is a reflection about the x-axis, because we're negating our y's, or we're changing the sign of our y's if our negative is out front. Okay. The +1 up in the exponent is going to be a horizontal shift to the left 1. So we're going to take our x's and subtract 1. And then the +1 out here, is going to move us vertically up 1. So we take our y's and we add 1. Okay. So let's go ahead and modify our tables one transformation at a time, starting with our horizontal shift. So now this looks like 2 to the x plus 1. So we're going to take our x's and subtract 1. And then our y stay the same. Then our next transformation is our reflection. So we're going to change the sign of our y's. And our x's stay the same. And then our last transformation is our vertical shift up 1. So we're going to take our y's from the previous table and add 1 to them. And then our x's stay the same. So now we're going to go ahead and graph it and find the location of our asymptote. So at -3, I'm at 3/4. -2, I'm at 1/2. -1, I'm at 0. 0, I'm at -1. And 1, I'm down at -3. So it should look something like this. And you can see it's coming up and curling right before 1. So our asymptote's going to be up here at y equals 1. Okay. Domain on all exponential functions is -infinity to infinity. Our range is our lowest y value up to our highest y value. So -infinity up to our asymptote at 1. Make sure you write your asymptote as y equals, not just 1, okay? All right, let me show you one more, and I'll have y'all try some. All right, first thing we do, identify our base, which in this case is E. Now, don't be scared by E. E is just the E button on your calculator. So we're going to start with e to the x. Again, we're going to use -2, -1, 0, 1, and 2. And when we plug these into our calculator, you should have either an E button or an E to the x button that you can use to apply these exponents. E to the -2 is approximately 0.1. E to the -1 is 0.3. E to the 0 is 1. E to the first power is 2.7. And E squared is 7.3. Okay. And then we want to identify our transformations. So the negative on the x is a reflection about the y-axis because we're changing the sign of our x's. And then the +1, which is also in the exponent, so that's also inside the function, is going to be a horizontal shift to the left 1. So we're going to take our x's and subtract 1. Okay, so we're going to do our horizontal shift first. So e to the x plus 1. We take our x's from the previous table, subtract 1 from them, which gives us -3, -2, -1, 0, and 1. Our y's stay the same, 0.1, 0.3, 1, 2. And then we're going to come down and do our reflection. So now our function looks like e to the -x plus 1. Okay. And all we have to do is change the sign on our x's. Take our x's from the previous table and change their sign. So +3, +2, +1, 0, -1. And then our y's stay the same. 0.1, 0.3, 1, 2.7, 7.3. Okay? All right, so now we should be able to graph it and identify the location of our asymptote. So at 3, we're at 0.1, which is just above 0. At 2, we're at 0.3, which is not further above 0. 1, we're at 1. 0, we're at 2.7, which is almost up to 3. And -1, we're at 7.3, which is not quite to 7.5. So when we connect our dots, we should get a decreasing function looking something like this. right? And we can see that our asymptote is going to be at y equals 0. So that means our domain keeps going left and right, negative infinity to infinity, and our range starts at our asymptote at 0 and continues on up. Okay? All right, so on the next 2 pages, there's 2 for you to try. So go ahead and pause the video and give those a whirl. See how you do when you're ready to check yourself, or if you get stuck, unpause it and we'll go over it. All right, let's see how you did. On this one, we should have started with exponential base 2. So I have it all filled out here. You can check your numbers. And the only transformation we had on this one was to move it to the right 3, which means we're going to be adding 3 to our x's. So as we add 3 to those x's, that will shift the graph over here to the right, which means the asymptote is still at y equals 0, and our range is 0 to infinity. Our domain is all real numbers. Okay, let's look at the next one. The next one, we should have started off with exponential base 2. So again, we start with the 2 to the x table. Then notice here we had a negative in front of the 2 and in front of the x, which means we have a reflection about both the x and y axis. So you can do both of those in the same table if you like. If you did a table for each one individually, that's totally fine too. So we change the signs of both. And then the last transformation we have is to move it up 3 because of this 3 on the outside of the function. So we add 3 to our y's. Once we add 3 to our y's and graph it, our graph should look something like this, which is an increasing function headed up towards our asymptote at y equals 3, which means our range is from negative infinity to 3, and our domain is all real numbers. Okay? All right, so that's the HSRV method for graphing exponentials. The last thing I want to go over, on this section is solving simple exponential equations. So we have this base exponent property that helps a lot with this. Because it says that if you have a to the x equal to a to the y, that's only true if and only if x equals y. So let me give you an example so this makes a little bit of sense. If you had something like 7 to the x equals 7 squared, this would only be a true statement if x is what? X would have to be 2, right? So what this is saying is if you have an exponential equation where both sides have the same exponential base, we can just drop the bases and assume that this means x equals 2. So that's our strategy, is to try to make both sides be written with the same exponential base so that we can just drop the base and solve the equation that's left over by the exponents. Okay? So here's our steps for solving. Let's go ahead and jump into an example. So on this one, I want to get the exponential base isolated. So I'm going to move 16 to the other side. And then I want to try to write both sides with the same base. And notice here, both of them can be written as base 4. Now don't increase the value, okay? You can't change the value. So I can't change this side into a 16 because I would have to square it. That's going to change the value. So always take the bigger base and lower it to a smaller base. Make it smaller. Rewrite it as a smaller base. So this one stays 4 to the negative x. 16 we can write as 4 squared. And now that we have 4 to some power equals 4 to some power, that means that the powers have to be equal. So negative x is equal to 2. And then all we have to do is divide off that negative. So we divide off our negative 1, which tells us that x equals negative 2. Okay? All right, we look at the next one. Both sides can be written with the same base, which would be 10. Okay? 1,000 is the same thing as 10 cubed. And notice on the 1,000, we have a negative x. So that exponent still needs to be applied, even if we rewrite it. Okay? Is equal to 10 to the x minus 8. And then before we can drop the tens, we have to make sure our exponents are completely simplified. So we're going to go ahead, when we have a power raised to another power, That means we have to multiply. So this gives me 10 to the negative 3x is equal to 10 to the x minus 8. We drop our 10s. It gives us negative 3x is equal to x minus 8. And now this is something nice and pretty that I can go ahead and solve for. So I'm going to get my x's together, which gives me negative 4x is equal to 8, and then divide off my negative 4, which tells me that x is equal to negative 2. Oh no, this is a negative 8. Sorry, there's a negative 8 up here. I just forgot to write my negative. Negative divided by negative is positive. So we get positive 2. Okay? All right. Let me look at a couple more, and then I'll have y'all try some. Okay? So on this one, let me see if I can zoom this in a little bit. These are really small the way they printed. All right. So with fractions, the easiest way to simplify them is to kind of think about them not as fractions. Okay? We're going to cover up the denominators and say, you know, if I just had 2 to the something equals 4 to the something, the base that I would want to write them as is 2, right? So this side I could rewrite as 2 squared. So then I just want to check to make sure that still holds with the bottom, right? If I was just looking at the 5 and the 25, I would rewrite the 25 as 5 squared. So really what we're saying is this fraction can be rewritten as the smaller fraction squared. So we could write this as 2/5 squared, right? But it already had a power of 11, so we have to make sure that that's still raised to the 11th power. Okay. Then on the other side, we have 2/5 to the 2x plus 4. And I can't drop my 2/5 until I simplify the exponents. So this gives me 2/5 to the 2x plus 4 is equal to 2/5 to the power raised to a power means I multiply. So that gives me 22. And now I can go ahead and drop my 2/5. So I end up with 2x plus 4 is equal to 22. And now that's something easy I can solve, right? So I'm going to subtract 4 from both sides, which gives me 2x equals 18. And then when I divide off my 2, that gives me x is equal to positive 9. Okay? All right, let's look at another one. This one, I could either write 4 as a fraction, or I could write 1/4 as 4. And I prefer to go in the direction where we just don't have fractions. So I'm going to rewrite this. So I'm going to come over here and just think about it for a second. If I have 1/4, that means I have 1/4 to the first power, right? And remember, if I want to take a base and move it up, I have to change the sign of the exponent, right? So I can move this up by writing it as 4 to the negative 1 power. So that's what I'm going to replace this 1/4 with. I know I can rewrite this as 4 to the negative 1 power, and then it's raised to the negative 2x. And on this side, I just have 4 to the 3x plus 2. Okay. Now I can't drop my 4's until my exponents are simplified, so I have 4 to the 3x plus 2 is equal to 4 to the, when I multiply these, I get positive 2x. And now I can drop my 4's, which gives me 3x plus 2 is equal to 2x. And then I can get all my x terms on the same side by subtracting 3x from both sides. So I get 2 is equal to negative 1x. And then I divide off that negative 1, which tells me that x is equal to negative 2. Okay. All right, so there's 3 for y'all to try. I may have challenged you, so let's see how you do. Go ahead and pause the video, work those out. When you're done, or if you get stuck, unpause it, and we'll see how you did. All right, so on the first practice problem, first thing we need to do is move our 125 to the other side by adding, which makes it a positive 125. Then 125 can be rewritten as 5 cubed. And then we could drop our 5's, which means that x equals 3. Okay? All right, let's go ahead and look at the second one. Now, the second one was a little bit tricky because we can't write we can't write 9 and 27 as 9 to some power. Okay, so if we can't rewrite them with 9s, we're going to go down smaller and write them with 3s. So 9 can be written as 3 squared, 27 can be written as 3 cubed, and then we can go from there. Okay, now when we have a power raised to a power, remember we have to multiply, or we have more than one term in our power, so make sure you distribute that 2 to both terms. So we get 3 to the 4x minus 10. Same thing over here, we have to distribute that 3 to both terms, which gives us 3 to the 3x minus 6. And then we can go ahead and drop our 3's. And we're left with 4x minus 10 equals 3x minus 6. And when we solve it, we should get 4. Okay? All right, and then the last one, number 3. This one was a little bit tricky because once we rewrite 49 as 7 squared, we know we can move it up to the top by writing it as 7 to the negative 2. When we drop our 7s, we were left with an x squared. So remember, when you're left with an x squared, that means you're either going to have to factor it or use quadratic formula, or one of the solving methods we've done so far. Okay, this one has nice, pretty small numbers, so I decided to try and factor it by moving the negative 2 over to this side and then using sum product. Okay, if you use quadratic formula, you should get the same answers. Either way, x equals negative 2 or negative 1. And that is the end of section 5.2. So you should now be able to complete that on my math lab. There's also a worksheet that goes with this section. I highly encourage you to do the worksheet, at least the worksheet, before you move on to section 5.3, because 5.3 is going to build on the type of graphing that we did in 5.2. So make sure you get both of those assignments done, and we'll see you on the next video.